because it does the compression. And
Oh, okay.
Yeah.
All right, done.
Great, thank you. So, sorry for those who are viewing the video, but we're going to start here. So at Why Shiny. So it's basically lets you kind of produce interactive figures that help users explore data. It's often used for things like dashboards. So like, if you want to show people kind of summaries of data, so how many patients were admitted through this particular department, it lets you kind of look at that, and it might give you something like a week-long summary. So how many patients did we admit this week through this department? I would say this is a tool. It's useful to know because it's actually becoming very widely used. And the nice thing is that it leverages R and its visualization tools. So if you know how to produce a visualization, you can now make it interactive and explorable. Any questions so far? And again, for people who are just joining, you can find the slides here at this link. And someone will post it into chat as well. So before we even kind of get started, we need to start learning about some basic Shiny app architecture. So while we discuss this, actually, I'm going to go into RStudio Cloud and I'm going to ask you to start creating your project. So I'm going to start. This is probably where you're going to start off. So RStudio Cloud is it's nice because it provides you with the ability to run R and on a remote machine. And so this is all free for you. But I want you, so you'll probably be in this place called your workspace. So what I want you to do is click these 3 lines over here. And that should open up the Spaces tab. You probably don't have as many as I do, but I want you to click on the Gradual Intro to Shiny. And you should be in the workshop. And what I want you to do is click on, you'll only see your view, you'll probably only see this one that says assignment. So I want you to click on that and it will open your project. So that's a good thing to do right now while we kind of talk about the basics. So let's go back to the slides. So Shiny is basically, this is what a Shiny app looks like. And this is kind of what the bare minimum of a Shiny app is. And this app itself doesn't do anything, but it's important to show you all of the different components of a Shiny app. So to start a Shiny app, you always have to call the library Shiny to load up the Shiny package. And you can see there are 2 main elements to an app. So the first one is called UI, and UI is short for user interface. And this tells Shiny, this is a part where you can add controls and you can add plots. Essentially, it tells Shiny what to display on the web page. So this is the thing that sometimes bends people's brains when you work with Shiny is that actually UI and server are kind of running simultaneously. And the server is a part that actually runs any R code. So if you want to produce a plot using ggplot, this is where you would put that R code. And then, so once you have defined these 2, to spin up an app, you can use the Shiny app command, and then you have to provide it the UI and server arguments to run it. So this is a different view. I just wanted to kind of emphasize certain things about the app. So this is kind of the format we're going to be using for these slides, is that UI is usually going to be on the left and server is usually going to be on the right. So the first thing I want you to notice is that, let's look at these, so you can see that there are parentheses. So fluid page is actually a predefined function. So this is something that you just need to know, because what you actually put in fluid page are arguments to the function. And these are all sorts of different user interface elements. So that it could be a plot, it could be a control. So the thing that I find a lot of students get tripped up on is that because it is a function, the arguments are separated by commas. So that is different than server. So if we look at server, and hopefully you read up a little bit about functions before we started this, you can see that server is actually, we are defining a new function. And the way you can tell that is that we start with like the function, it says function, and then we have our arguments, input and output. So the main thing to notice is, so notice in orange here, these are curly brackets. So this is where you can put like multiple lines of code. So that's just one thing to keep in mind, is that, and we'll look at this more as we start adding controls into our plot. Are there any questions so far? Okay.
Oh, I know we have one question that was
Sure.
accidentally sent to me from Sam P. Sam, did you want to post your question? There we go.
Can I send someone? Yes. So that's a good question, Sam. So Sam is asking, can you send someone the web link to your interactive Shiny plot? Yes. So that's the cool thing about Shiny, is that they don't have to have R installed on their computer. So that's why it's basically your app is hosted on a remote machine, usually a server. And the thing is that the server actually has to have R installed on it. Hopefully that answered your question, Sam. So yeah, that's the really cool thing. If like, everyone had to have R installed on their machine, this wouldn't be that helpful. So thank you for pointing that out. Okay, so let's go on to the next slide. So we've now seen that there are two components to a Shiny app. So they can only communicate with these two objects that are known as input and output. And I have a diagram that kind of shows how this works in a second. But as we mentioned before, both the UI and the server components are continuously running, and they're listening to each other. But they can only kind of communicate through these input and output objects. So let's talk about the UI side. And I know this is kind of abstract right now, but we will be getting into a more concrete example in a second. So what it does is it will listen for changes in the output object, and it also will put information into the input object. So the kind of information it puts into the input object are information on the state of controls. So if you had a slider, for example, it would output the value of that slider into the input object, which the server object can access. On the other side, it's also listening to the output object. And if the server is generating any sort of plots, it's going to basically be able to grab those and generate them on the screen. On the other side, so server is kind of the opposite. So it's going to be listening to the input object, and it'll put info into the output object. So it passes on plots and tables into the output object. And one thing to note is that these names are fixed. You cannot change output or input, but you can change the names of things that you put into these objects. So we'll be looking at an example like this. So this is, we can put an object called myPlot into the output object using this $ notation. It also listens to inputs for changes in controls. So I know this is very abstract, and you probably all have a lot of questions, but we'll go through an example really slowly. But that's just to kind of set the stage. So we are going to be using this data set. It's called Biopics. And this is from the 538 package. And you can see that it's basically biographical movies, and it has some information about that movie. So you can see this is a movie called 10 Rillington Place. You have information on the box office, how much money it made, if it is available, who the director is, who the subject is of the picture, what the type of subject is. And then it's also made to ask questions about race. So was there a person of is the subject a person of color? Do we know the subject's race? It's also the gender and who the lead actor is. So this is a very rich data set, and it's kind of ripe for asking lots of different questions about it. You can think of multiple ways to kind of slice this. So our movies, I don't want to open any wounds, but our movies that have a criminal subject, do they make more money than movies that have an athlete as a subject? So this kind of thing. So this is a reference if you ever want to kind of refer to all of the different variables in our data set, you can always come back here. Okay, so we talked about the architecture of our Shiny app. So let's start by adding a plot to our app. So you should always start out with like a ggplot that you can, or a plot that you can already make. So we're going to take this plot, and it's a scatter plot of year release versus box office, and we're going to color the points by type of subject. And we're going to use geom_point to make this into a scatter plot. So if you have used ggplot before, you're probably used to seeing AES here instead of AES string. But the AES string is another way to map variable names into aesthetics. So but you can provide the variable names as characters. And this is important because this kind of lets us basically change, like for example, we're going to change out the color to the variable that we're going to color by. And this is kind of a way to kind of make like the controls compatible with our ggplot. Any questions so far? Okay. So we talked about the output object. So let's start on the right side here. So what you can see is that we are going to assign something into output $movie plot. And again, this name is the name of the object after the $ is arbitrary. You can decide whatever name you want for that. And to actually put the plot in, we need to use this render plot function. And one thing to note is that render plot, so it is a function, but it also has a curly brackets. So again, when we see the curly brackets, that is a way that we can kind of provide multiple lines of code. Technically, it's called, I can't remember what the technical name is, but we don't have to worry about that too much. So we haven't put any code in here, but I'm just showing you the general kind of structure. It's so we can kind of see how where the UI is going to get that information from. So if we look on this side, we have added this function called plot output. So where did we get this argument movie plot? Anyone?
From the output of the server?
Yes. So it's from, so yeah, and the main point is that this, to actually display the plot, this and this, so this argument movie plot, they have to match. And this is something, I make this mistake all the time, especially like with capitalization. It might put like, you know, capital M, but, and sometimes when you're not, your plot isn't outputting, it might be something like that. So something to be aware of. So anyone have any questions about this? Okay. So we've added our render plot and our plot. So we added our render plot to our server, and we added our plot output. So now we can actually add our ggplot statement in. And we're going to actually do this in the exercise, but I want to take everyone through the entire exercise, and you'll have this as a reference as you're kind of working through it. So we added our ggplot statement in. This is a full app in itself. It's only going to display the plot, but it's a good start. Okay, so we've only added a plot to our app, but now we want to add a control. So you can add controls into the UI side, and they all begin with, or the end with input. And I'm going to show you at the end this shiny widget gallery that lets you be able to kind of see all of the different kinds of inputs and widgets that you can use to select things. But this is called a select input. And this is an example of what it would look like. So it's a drop-down box, and it will let you select one of these one of these different variable names. So one thing to be really aware of is, remember we had the we put in our we defined our our movie plot as output $movie plot, but so all of the input functions have this argument called input ID, and this is where you define the object in the input object so that server can read it. I haven't shown it here, but this is a character vector, and it contains country, type of subject, subject race, and subject sex. So we want to use this to control the variable that we're going to that we select with this input. So we want to map the color to these different variables in our data set. Any questions so far? Okay, so we've defined an input. So where do we put it? So you can see that we put it right after our plot output. And the thing I want you to remember that Fluid Page takes arguments and not lines of code. So you have to put this comma after it. And we're just putting our select input into the into our UI object, or and this is a mistake I make all the time. So don't forget the comma when you're adding new controls or new plots. So we are going to wire this into our color aesthetic over here. So it's right now it's just static. It's just colored by type of subject, but now we can make that dynamic. So what we do is we can, again, this comes from the input object. So our input ID is color select. And so we can get that information out of the input object with input $color select. So essentially we have wired this control, the select input box, into our plot. And so now we can change the color dynamic, the variable we color by dynamically. So this is just, and I apologize that the names aren't quite the same here, but this is just kind of summarizing the flow. And one of the things with Shiny is to always kind of think about the flow of information. So what happens is that, you know, someone goes to the app and they say, oh, I want a different variable to color by. So that goes into the input object. The server can see that updated value by referring to the input $color var here. And then you can use that in your render plot function to put it in as an output into the output. So we're assigning it to output $box plot, and then you can display the changed plot with plot output. So to kind of make this a little more clear, so let's go into the project, and we're going to open this file 01 app basics. So let's take a look at the project. So I'm going to open it up. Hopefully everyone has opened up the workshop project. If you're having issues with that, please email one of the TAs. Oops. So this will happen. Don't worry too much. Just reload. Okay. It will work. I
So
swear.
Ted,
Yeah.
this happens a lot when there are multiple admins logged in. So I wonder if you could just go in and like make all of the TAs not admins anymore.
Okay, good point. Just a sec. Just have to remember how to do that. Okay. We'll make you all contributors. Thanks, Pirette. Okay, so this should now work now. So I'm going to go back into projects. And I am going to open mine. So this is the projects. So what I'm going to do, if you are in the projects folder, you can tell that you're in the project folder by this little area right here. So I'm going to go into this file in this folder 01_app basics. And I'm going to open this file 01appbasics.rmd. So when you're ready, just hit yes in the participants tab, just so we know that everyone's all set. Oh, thanks, Mary Jane. I'm not email. Okay, I'm just going to wait a few more seconds just to confirm that people are opened up in the project. Okay, so we've got about half of the people, I guess. I'm just going to give people a few more seconds. And again, if you're having any issues, you can message any of the TAs privately. So don't feel like you're holding everyone back. Okay, so I am going to start. We're going to go through. Go through the basics of building a Shiny app piece by piece. So again, have the slides open just as a reference. So we are in what's called an R Markdown document. If you're not familiar with R Markdown documents, they're they're a way of reproducibly sharing code and output. But we're actually going to be building Shiny apps within this. So the main thing is that to note with R Markdown documents is that there are these play buttons, and we're going to be using, and everything that's kind of gray is a code chunk. So we are going to run this by pressing the play button. So I'm just on line 6. So I'll press that. So we're going to load in the libraries that we need. So we need the Shiny library, we need ggplot2, and we need the 538 library because we are using the BioPix data set from it. So this is a bare minimum Shiny app that we discussed before. So again, with this, so you define the UI and the server, and then you can run the Shiny app using the Shiny app function. So if we run this, you'll see that basically it's blank. There's nothing in it, but that's okay. So,
Hey, Ted, can I clarify something?
sure.
You wanted everybody to create their own derived workspace, right? Or project or whatever. They're
Yeah.
not all supposed to be using yours. Okay.
Yes, exactly.
Okay. Thank you.
Thanks, Mary Jane. Just a second. Yeah. I have to, just a second. I have to be, I will be back. Sorry. Apologies. Okay, so we have started an app and it doesn't have anything in it. So I want to show you how to stop the app. So in this console pane, you can see that there is the stop button, and it says, if you mouse over it, says interrupt R. So we're going to stop the app because it's not actually doing anything. And I'm not exactly sure why it is giving us this error, but it's okay for right now. So that's the basic idea. That's the most minimal Shiny app that you can make. Not very interesting, huh? Okay, so we're going to fill in the server UI and server objects. And one thing to note is that the name, input, and output, they're fixed, but the names of what goes into them aren't. So you decide those names. So we're going to add our ggplot to our app. So this is, again, this is our ggplot that we're going to add into our app. And you can see that it is box office versus year released and colored by type of subject. Any questions? Does someone ask? Okay. So this part is going to go into the server portion of the app. And again, we have to assign it into an object, into our output. So input, the UI can see it. So this is what we showed on the first part. And then we're going to also be able to display it. We need to add this plot output in our UI portion. So we've done that here. So I just want to show, this is, so you can see we added our plot output. Sorry, the names are a little inconsistent. I was changing the names, but you can see that we're assigning into paired underscore plot. We have our, and within our render plot, we've got our ggplot that we want to render. And then we've got our plot output function that will actually display it on the UI. So if we run this, and I don't know why it always, sorry, but you can see that we generated our plot now, but there's no controls for it whatsoever. Just a second, let me see if I can, okay. So you can see that it's just a static plot here, not that interesting. So let's, again, so we can hit our stop button and stop our app. So we added in our ggplot, but it's not dynamic at all. Okay, so now we're going to add our select box. So we define that as a select input. And we refer to it as, we're making the ID. So this is what comes out of the input object as colors underscore select. Remember that you have to have a comma after each of these because these are arguments and it's not line by line code. So we've got a comma after paired plot, and then we have our select input. So one question you might have is, where does this, you notice that one of the arguments to select input is choices. And you can see there it is categorical vars. So we actually need to define that. Does anyone see where we define that in our new version of the app? And you can just tell me the line number.
Is it by type of subject?
Yeah. So so someone pointed in line 147. So do you see this? We've got this categorical vars variable, and this is a character vector, and these are the names of all of our different variables that we want to color by. Does that make sense so far? And we haven't wired it in. So what if we run this, you can see we've now added a control. And sorry, again, it's really kind of irritating that we've added a control, but if we change it, nothing changes. And that's because we haven't wired the control in. And I'm getting an internet connection is unstable. So if you can't hear me, please let me know. But
we can hear you, and it looks like you have a question in the chat.
Yeah. So the question is, should the variables match the data set? Yes, exactly. And remember, R is case sensitive. So if like, let's go back to, I'm going to stop the app right now. These have to have the same case or capitalization as the column names in our data frame that we're working with. So the biopics data frame. Okay, so this is kind of the exercise that I want you to do. So I want you to add, I want you to wire that to the color aesthetic by adding input color select. So we're now on the exercise on line 178. So I want you to just put in input $color select. And when you're ready, type in, or put yes in the participants tab. So I'm going to do it myself. If you try to run this, because we've got these dashes here, it's not going to run. So we need to make it so that it works correctly.
I just want to note, in case people are confused, when Ted is saying yes in the participants tab, he's talking about the reactions on the bottom toolbar of the Zoom window, which keeps us from cluttering the chat.
Okay, we have some people are kind of getting it. So I'll wait a second. And if you're having any troubles, please either message the TAs or message Mary Jane, and we can get you sorted. Okay, we have about 10 people. Okay, Randy, when you get that error, make sure that you've stopped the previous app. So I'm going to show it here. So you can see that it says listening on I have that same, it's not really an error. It's it's R telling you that that's what's going on. So to stop that, you just want to hit the stop button right next to and if you mouse over it, it says interrupt R. So that should let you start to stop the app, and then you should be able to run the new one. Okay, so we have about 10 people so far. Are there any issues that I should know about, TAs?
I've had a few direct messages. Did you? Okay, and I've been distracted trying to chat to people. Did you address Randy's question?
Yes.
Okay, and then Sam M says that they don't have access to the practice and wasn't under the gradual intro to Shiny M. And again, because I'm not an R programmer, I just changed my name so it doesn't say TA.
Yeah.
just so everybody knows, the reason why I'm traffic director is because I'm a Python programmer, not an R programmer. So I'm here to kind of do administrative stuff. Anyway, I'll put myself
Okay,
back.
so for everyone who's having issues, can you see the gradual intro to Shiny Shiny projects page?
Yes.
So what have you created your own project by clicking on the assign, like it should say my name and it says assignment workshop?
Yours says continue in workshop, and I opened it, created my own, but it just had a coding for like the geysers, not anything like what you're showing.
So yeah, so you need to open up the workshop project. And I think you tried to make a new app, and we're not doing that yet. We're actually just working with the notebooks. So where we are, so if I click on workshop, that should derive it. And you will probably you can tell where you are by looking at these. This is basically your location. So the bottom folder is always called cloud, but you should be in this project folder. And if you go into 001_app basics, and then click this 01_app basics.rmd file, you should be where we are.
I'm seeing a thumbs up from Sam.
Ted, we can't hear you.
Oh, okay.
There we go.
Can you hear
I
me
can
now?
hear you. Mhm.
Okay, I'm getting an internet connection is unstable. Okay, so we've got some people, and again, don't feel like you're holding us behind. Like I really kind of scheduled this, so I want everyone to be able to run this. So if you're having any issues, please reach out. And again, if you need, don't feel like you're asking too much by asking for one-on-one assistance. I mean, that's why we have TAs, and we want to make sure that you can get through this. Okay. So for those who've kind of gotten to this point, that you've wired your you've wired into the color aesthetic. So input $color select. We're going to try running the app now. Oops, and this is slightly different. So you'll notice that our control is on top. But now that we've wired our control in, you can see that it now works. So we can change the coloring by like these different categories. So you can see this is colored by gender. I'm not going to talk anything about that. I'm not going to go there. But So this is like kind of the first step about building an app, is like being able to kind of add a control and change the aesthetics of a particular of color in this example. Any other questions, or are people still trying to figure it out? So does anyone have any questions about this so far? Okay, so we've been at this for 55 minutes, so let's take a 5-minute break right now and just kind of get up and stretch. Always find if you're getting frustrated with something, taking a short break, maybe having some coffee or something like that can help you out. So I will be back. We'll be back in 5 minutes. So the TAs will be sticking around if you have any questions, and you can help. They can help you out. So I'm going to pause recording. TAs, where are we? Are people needing help?
I have not received any requests for breakout rooms.
Okay. So just so we can, let's just take a little time. Pierrette did mention this and Eric did mention this. I do want to kind of talk about all of the different kinds of inputs and controls you can put into a Shiny app. So just a second, let me. Okay, where is it? Gallery. So these are all of the different controls you can add into a Shiny app. I am going to paste this link into chat. So these are all of the different kinds of controls. So for example, you can use, like if you have a checkbox. So if it is checked, and this is nice because it shows you what the value is. So if I have a checkbox, what's coming out of that checkbox is going to be a Boolean, so true, false. So if I uncheck the checkbox, you can see that the value is false. You can also have like a checkbox group, and you can see that that will let you. And the nice thing about this widget gallery is that you can see the code that was used to generate it. So it will give you the name of the control. You'll usually have to go into the UI, but you can see that there is the name of the control is called checkbox input. And it gives you kind of what the default So this is the input ID. So this would be identified as checkbox. This would be, and this is what the label is on the app. So you can see this is the label like next to the checkbox, so choice A. And this is what the default value is. So by default, it's just selected as true. So if we change that, you'll see that it changes to false. but this is a very nice resource because I never remember the names of all of these different kinds of controls. So you can have things like numeric inputs. So like, for example, you can increment it or you can put in a number. So 50, for example. You can have the select box that we looked at. You can also have sliders. So sliders are very handy. You can see as you move the slider, that changes the value of the slider. And thanks, Daria. So she's mentioning, so for any of the widgets, you can kind of code run through by just using the to look for the help under the different widget or input. Sorry, I don't like that they called them widgets because I think they should have just called them inputs because it's a little confusing. Okay, so how is everyone? Okay, do you want to move on? Okay. So let's get back into the slides. So now we are going to do what's called a reactive data set. Worry too much about this figure. We'll go over it later. So oftentimes one of the controls that you do want to provide for someone is being able to kind of filter a data set down. So what we have here, so we're using the BioPix data set, and we are filtering by year release. So we want year release to be greater than or equal to 1917. So we want to actually make this value, we want to make this value 1917 dynamic. So that's great, but we can't use what we've currently learned. We need to learn an extra concept called what's called a reactive expression. And what this is, it lets you kind of create a data set that will listen to an input. So what does that mean? Let's go over it. So the first thing to note is that this is going to be in our server side, and we will define it as BioPix filtered. So notice it's not in output because we're not going to use it in output. So this is going to be a data set that is we're only going to work on the server side with. So to define a reactive, you need to use the reactive and then parentheses and then curly brackets. And the reason, again, is because you want to have multiple lines of code in this reactive. So again, this is called, the long name for it is called a reactive expression. So this is a way to make a data set that listens to a change in input. So you can see that we have, instead of 1917 here, we've added input $year_filter. So any idea where that came from, where we're going to put that $year_filter in on the UI side? Yeah, well, so that was a great guess, Roman. So it could come from a select input if we put in numerical values, but Sammy is right. It's going to come from a slider input. So we're going to use a slider input, but select input could have worked as well. Okay, so again, thinking about the flow of information. We've got a slider input, and sorry, I have abbreviated ID because it didn't fit into the box. So this should be input ID. And so our slider input has the input ID of year. So again, we put in our data set into a reactive, and this reactive is going to listen to that input and put $year. So when any changes happen on this side, what's going to happen is this data set gets filtered down by that value. So say this is like 1920. So this value is going to become 1920, and the data set is going to become dynamically filtered. And we haven't talked about how we use that dynamically filtered data set, but we will talk about that in a second. That goes into a render plot. And note that there are these parentheses after my data. And that's an important part, and we'll go over that in a second. So when the data gets changed, the box plot also gets changed, and then the new box plot comes up. So this is our control. So this is much like our select input. We have an input ID, so it's going to be year_filter. We need to provide and then this is the name that's going to go next to our slider input to give people instructions. This is the minimum value of our slider. This is the maximum value of our slider. And the value argument is the current value of the slider. So now we can add, so again, we're not building on the other app. We're just kind of working with the slider input right now. So we added plot output after slider input. And it's, again, the ID is year_filter. And again, don't forget the comma. So that was in UI. So the changes we need to make in server for this to work. So we talked about defining the reactive, but the way we react is by using the name and then following it with the parentheses. So this indicates to R that this is a dynamic data set, and that you can basic, like, any changes that we make to our slider is going to be happen into our scatter plot. So one thing to remember is that when you are calling a reactive, you always need to have the parentheses after it. So like in our example, it's biopics_filtered, and then the 2 parentheses. So now we're going to go back into our studio project, and we're going to start working with reactives. So again, we're in the project folder. I want you to, there's a folder called 02_reactives. And we're going to be doing our work in 02_reactives.rmd. So much like we did, we're going to work with the simple form of our app. So the first thing we're going to do is we're going to add in our slider input control, much like we said before. And let's take a look at what the app looks like. So we're just going to run this current chunk. And we can modify this, and you can see that nothing happens because we haven't wired our control again. So what we want to do is we want to stop the app again. So again, hit the stop button on this part. It says interrupt R. So we're going to kind of take this dplyr code, and we're going to make it react to our slider. So to do that, we need to change this to input. Anyone know what this should be? Input $. And it shouldn't be any of the, yeah, exactly, Sammy. So year filter. So that's going to be how we wire our slider input into our reactive. So again, we need to put our wire statement into our reactive expression. So this is the exercise for this one. So what I want you to do is wire the slider input into the reactive using the correct input. And when you're ready, just hit yes in the participants tab. Oh, great question, Natalie. So it was called, oh, and I'm sorry, this should be, if you notice here, this is your slider, this is inconsistent. So the reason you know it is because the slider input had that ID. So this is where that identifier comes from. I'm going to change this to year underscore filter, just so it's consistent with everything else.
But I think there's a typo in the, where is it? The reactive, it's curly bracket and then parenthesis, but I think the
Oh, okay. I am very sorry, everyone. I'm going to post the fixed version of this. I swear I tested this, but I guess not. So on lines 106, so I want you to cut and paste. So for BioPix filtered, I want you to cut and paste this code in. So this is fixed. This should be fixed. Yeah, so where are rainbow parentheses? Ah, nice. So for line 110, it should be your, oh yeah, thank you. And I'll paste the fixed code into.
Ted, we have a question. What should line 70 be? It was sent to me privately.
Line 70. So this was just an example. So this should just be, in my example, this was just lines BioPix filter less than 1917. Oh, sorry, this should be year release. I really did work hard on this. I'm sorry that there are these issues with Workshop. So let's try 1950. So you can see this has all of the movies that were before 1950.
There was also a question in the chat about the pipe function
Yeah.
not working.
It looks like Sam answered that. So let's kind of go through the exercise together. So we see that our input ID is year_filter in my version. So what should this be? Input Yeah. So Aaron, you're completely right. So it should, well, in your case, it should be year slider because I think that's what the original name is, but mine is called year filter because I changed it. But yeah, so that should be either be year slider or year filter. Okay, so what should go here? So Sam is saying biopics filtered with the parentheses. So this should now be an app that has our reactive data set. Sorry for anyone's having issues. It's that, like Sam said, just put library tidyverse here. Okay, so we wired it into our reactive expression, and now we're using our reactive expression in our render plot. So let's try running this code. So depending on how you have the statement set up, you're going to have to drag the slider. So this, you can see that these are all movies that are before 1992. We drag it all the way to the right, we'll see the entire data set. So we've now made a reactive data set, and it now responds to a control. Any questions so far? Are there any questions coming from the to the TAs?
None here.
Okay. Can we add, so yes, we can add the previous selection to the code. That's going to be the final thing we look at. I just kind of took these out, so like the code is like really kind of stripped down. At the very end, we'll look at something that combines all of the concepts that we put together. So I'm going to stop the app. If you have gotten it to work, just hit yes in participants. And if you need help, we'll definitely wait a little bit to make sure that everyone is up and running. And for everyone who's feeling a little frustrated, what I will say is, like, kudos to you for like working at learning this. This isn't easy. So just don't beat yourself up about it. These are kind of difficult concepts, and like, I've been teaching this for several years, and I don't think I have figured out the best way to explain this yet. So. And if you want to look at what the code should look like, and this has kind of messed up, this is what the code should look like. This is the right version of the code. This is the final one. So if you just scroll down to line 131, the final app, you should be able to run this. So all of these have kind of the final answer. While we're waiting, I just want to mention, so we have been running apps from an R Markdown notebook, which is not the way you usually do it. But the reason I've done this is just to kind of split the exercises up into pieces so it's easier to understand. So I want to just talk about how you usually kind of specify a Shiny app. So if you go in our React 02_reactives folder, if you just open this app.r file. So Shiny apps, the structure is usually they are in a folder, and the app code is always called app.r. There is a other format called UI.r and server.r. I don't really use that anymore. This is usually how I teach it. But you can see this contains everything in that same code block. So to run this code, you can hit this. You'll notice that because it's named app.r, RStudio is smart enough to know that, oh, it's an app, so you probably want to run it. So you can hit this play button here that says run app. And this is kind of a simpler version of the app, but you can see that, yes, it works. Yeah, so the color, I removed the color select input for this example, sorry. Okay, how is everyone feeling? You want to move on, or do you want to keep on working on this?
Ted, I'm getting a question, just a refresher about the reactivity, and just kind of going over that one more time.
Sure. Yeah, no, that's why we're here. So again, like we originally had a, let's go back into the notebook. And I will say reactivity is actually a really kind of slippery concept. So we started with the idea that we wanted to make this filter statement dynamic. We wanted to be able to like have it react to the input from our UI. So this is just an example. So input, so we are just filtering, so year release, less than 1950. So this was going to give us all the movies that are 1950 or that have a year release of 1950 or less. And if you run that, you can see that it filters our data. But we want to make this part dynamic. So to make that dynamic, you have to put it in what's called in this reactive function. And because it's multiple lines, remember, so the function is usually defined with the parentheses, but we need to have our curly brackets in here as well. So that's just the dplyr statement that we used before. So when we want to use that in our code, what we do is we call it with biopics underscore filtered and then parentheses. So let's go through the exercise again. So here we have defined a slider input, and its input ID is year underscore filter. So we need to wire that into our reactive expression. So whereas before this was 2014, you can see now that we've wired in our slider input by referring to it as input $year filter. So this data set, this will basically, every time we change the slider input, this is going to dynamically filter that data set down. I'm going to change this value to 2014 because it's a little easier to understand. So before, when we put in our ggplot statement, what we had here was just biopics. But that is just the static data set. So instead of the static data set, we want to use the that it's a dynamic data set, we have to follow it with parentheses. So now we've wired our control in, and now our ggplot is going to dynamically change whenever our dynamic data set changes. Is that a little more clear? And I will say this idea of kind of a dynamic data set, it's a very foreign concept. It took me a while to really get it, so don't beat yourself up if it's not immediately obvious. So take a look, just kind of keep on working at it, and like I'm always happy to answer questions after the workshop if you need help. So why wouldn't you always just make the data set dynamic? So it depends on the research question that you're asking, Roman. So this does take processing power. So for example, you might have a really big data set, and to like do this filter operation, it might be very expensive. So a lot of the apps, so a lot of the times you just want to have a static version of a data set, but this gives you the option to kind of subset it as people want to subset it. And oftentimes what happens is someone has a view of the kind of entire data set, and there'll be controls to filter the data set down so that they can examine different subsets. So these are all good questions. Anyone have any other questions? Okay, so I'm going to move on. So we're going to be talking about the last concept. Again, thanks for sticking it out. So we are going to be talking about tooltips. So among all of you, has anybody heard about tooltips? Yes or no? I will say that tooltips, yeah, so a lot of people haven't heard of it. It's one of those things that you might not think you know what it means, but when you see it, you'll be like, oh, okay, that's what it's called. So we're going to add them into our data set with this package called Plotly. So Plotly, what it technically is a JavaScript library, way of making your plots even more interactive. And the way we access them is that we use a Plotly package in R. So just as an example here, so this is what a tooltip is. So if I mouse my mouse over different data points, I will get information about that data point. So this is what the Plotly library does. And you can actually make these, if you don't need to do dynamic filtering, you can just make a Plotly illustration if you just want to have the tooltips. And a lot of people do that by itself. So what I'm showing you here is how you would basically make you're going to make a ggplot, and then you're going to make it into a Plotly plot. So first you define your plot, your plot as my plot. And this is just the ggplot statement. And I apologize, like I couldn't get this I was getting some errors in this output, but then you just run the ggplotly my plot. So technically you wouldn't have this hashtag here, but I was just using it because I was getting an error in the output here. So when we mouse over the data, any idea where these values are coming from? I don't know why my mouse might be a little screwy right now. So I don't know why it's not. It seems to be highlighting the coordinates a little wackily. So these values for the plot are actually coming from the data itself. So remember, each point is a row in our data set. And so it is just, I don't know why the pointer is so screwy right now, but hopefully it's working correctly for you. But you can see that for that kind of teal point, it's a historical movie. You've got the box office and the year that it was released. Yeah, so Roman, that's definitely where it actually comes from. It's actually coming from AES string. And what we will see is that these are just kind of, these are just kind of the values that we've set in our aesthetic mapping, but we can add more information by adding in what are known as kind of dummy aesthetics into here. So if we want to add more tooltip information, you can see that we're at, I've added an aesthetic called title. If you are familiar with GeoMPoint, you'll know that there is not an aesthetic called title, nor is there an aesthetic called director. But this is a way to tell Plotly that we need this extra information in our tooltip. So if we mouse over our, our plots right now, you can see now we have more information. We've got type of subject, we've got title, we've got the director, box office. The subject was Sunny von Bülow. And, so we have extra information. So we can add tooltip information and again, these have to be columns in our data set. These just can't come from nowhere. So essentially you are just like with the plot, you're showing like kind of three variables of information just as the actual plot, but you're actually providing extra information that you can get when you mouse over. Any questions about this? And I have been working on how you set the order on this. I didn't have time to kind of put the code in. I just wanted to kind of introduce you to the concept because this is a question and to even give you the language of what it is. It's called a tooltip. So notice that this was not in any of our, this wasn't actually in a Shiny app by itself, but I'll show you how to add it into a Shiny app in a second. So remember our two things that we used in UI, we used plot output in our UI. So we need to change, for a Plotly plot, we need to change that to Plotly output. And instead of render plot, you need to use the render Plotly function. And just to kind of reflect that, you can see in yellow, this was the Plotly code that we were just using before. And then here in the blue, this is where we've made the changes to our plot output. Our plot output now becomes Plotly output, and our render plot becomes our render Plotly output. So this is the last thing we'll be talking about today. So again, everyone who stuck around, thanks for sticking around. So we are going to go back into our project folder and go into Tooltips Plotly. So again, this is our original plot. And then we've called it my_plot here. So we can call the ggplotly function with ggplotly myplot. And this should work better. One or the other. I don't know why it was causing such problems with the mousing over, but you can see as you mouse over different data points, you get more information. So say we only wanted to show box office and year release. We can limit the information that we show by using this tooltip argument. And so we are providing a character vector of box office and year release. So when we run it, you can see now we're only showing the box office and year release. So this is, I believe this is the entire app that shows you how to add the plotly object into our ggplot. And again, we don't notice that we don't have a control here. This is just to show you how to add a plotly plot. So as an, I'm going to leave this exercise to you to do later. But like what I want you to do is basically add more aesthetics into the AES string statement. And these are like the different names, the columns, so you can add that information into the tooltip. And then I want you to modify that in the app so it displays. So this is the final app that works. So I'm just going to kind of wrap things up. So I talked about the usual structure of a Shiny app with this app.r file. So let's just take a final look at an app that integrates everything together. So in this 04 underscore full app, you'll see there's just an app.r file. So I'm going to close these things down so it's not confusing. So here you can see we've added back our select input and our slider input. We've got kind of the dynamic filtering. Everything is in a plotly plot. And I think I was trying to play with the formatting. I didn't quite get there with this, but let's try running this app. Okay, of course it's broken. So I'm remove this line. So on line 40, remove this scale Y continuous. And so 40 and 41, just delete that. I'm going to stop it again. And it again. Okay, so I will have a fixed version of this, and I don't know exactly what's going on here. I will fix this. I was trying to be fancy with the formatting. Okay, well, sorry. That's kind of the final app. So I just want to wrap things up. So when you're making a new app as a project, you'll use the new project under File, and then you want to create a new directory, and there'll be an option for a Shiny web application. Then you'll provide a name for the app, and then it'll create an app.r, a sample app.r for you and set. So we talked about the widget gallery already. So again, when you're looking for controls to add to your Shiny app, this is a great place to look. I didn't talk anything about ways to lay out elements of your application, and that's because it's kind of its own thing, and we didn't really have time to talk about it. But we saw one layout style, which is called fluid page. So if you're interested in learning how to place controls in particular places and plots in particular places, you can look at the layout guide. There's also a system called Flex Dashboard. And I find this actually easier to use than using fluid page, but it takes a little extra learning. When you're starting out, I would just start out with the basic layouts of a Shiny. So if you want to next here, so I have a link here that talks about kind of where you can go thinking about where to go next. Just want to talk a little bit about like if you want to host a Shiny app at OHSU, Oregon Clinical Translational Research, I can't remember the Institute, sorry, has an RStudio, it's what's called an RStudio Connect server. So this will let you publish a Shiny app, and it will be accessible as an app within the OHSU firewall. The one drawback to this is it requires a developer's fee and a user's fee. Although the user fee is mostly if you just want the app to be private. If the app is just publicly available within the firewall, you just need to pay the developer's fee. Okay, so the question is, does it know all of the common libraries, or do you ever need to install any? Are you talking about the RStudio Connect server? Okay, both Shiny apps and the Oaktree Studio Connect server, they use a technology called RENV. So as long as you have the correct packages installed on your machine, it's going to basically find all of the versions of those packages and install them on the Shiny server or the RStudio Connect server. This also is the case for Shiny apps as well. So that's the really nice thing. You don't have to worry about all these packages being installed. The process for publishing includes that. So if you want to have an app that's just kind of accessible to everyone, there is, thanks for bringing that up, there is a service called shinyapps.io, and it lets you host Shiny apps externally. You can sign up for an account. There is a free version, but you only have a limited number of access hours. So for example, I think you're limited to something like 20. So like 20 hours of people viewing your app per month. So if you want more than that, you have to pay for it. And just, you know, as a data steward, I have to warn people to be very careful about PHI. You don't want protected health information out in the real world. Be very careful about that. So if you want to put an app on shinyapps.io, you need to install this package called RS Connect. And then when you run the app, there's going to be what's called a publish button. And then you will ask you for all of your account information, and it will give you all of the places that you need to look on shinyapps.io to put in that information. So again, you know, I couldn't teach you everything in this workshop, but you should now know enough to start looking at learning from the examples. So this is the RStudio Shiny gallery. There's a lot of really fancy ones at the top. So scroll down and look at the demos. There's lots of different apps that kind of show you basic kind of concepts that you can build on with the knowledge that you now have. Just some tips, thinking about like, so you can have it dynamically compute statistics, but if you can pre-compute them for your data set, try to pre-compute them as much as possible in advance, because you do take a performance hit. I will send a link out to talk about, like, there's more information about how you dynamically update a UI. And like the major case would be is if you uploaded a data set into the app, like it would then update like the select box for all of the variables, for example. There are a lot of HTML widgets. This is kind of a technology that works with Shiny, and there are a lot of the really cool visualizations are actually written in JavaScript, but people have written these kinds of packages that let you publish these JavaScript visualizations. Let's just end it. So this is my suggested reading. So Mastering Shiny by Hadley Wickham. It's now becoming kind of the text to kind of go further in Shiny. So you should now know enough to kind of jump into Mastering Shiny. If you're more interested in Plotly, Carsten Sievert has this web book called Interactive Web-Based Data Visualization with R, Plotly, and Shiny. And just some acknowledgements. So thanks to Biodata Club. Thanks to Jessica Minier. So we gave the previous version of this workshop together. Thanks to all of the TAs. And I am very sorry, Mary Jane, you're not on here. We'll fix that. Also to Vivian Peng, she gave me the idea of displaying the UI and server kind of in side-to-side windows. So I will end it there. Are there any questions? I'm going to stop recording.